Hello everyone. This is the part 2 of section 2.7 and in this section we are going to take an application of the slope of the tangent line that we took in part 1. So velocity can be seen or can be considered as a perfect application of the slope of the tangent line. So the position, if I have the position curve s of t, which is dependent of the time, s of t is the position curve, and if I have the position curve here, for example, this is s of t. What is the velocity? The velocity is at any point t is the tangent line, the slope, of the tangent line at any point. So here the tangent line, the slope of that tangent line, which we took two formulas for that tangent line, the slope of the tangent line, and one of them was this one. So the slope of that tangent line is the velocity v of t at this point. Let's go directly for an example. Okay, so in this example, just a reminder or recall that s of t is equal to 4.9 t squared. This is the position function. Okay, I have this position function is known, something that is known. Okay, I have the position function and it's equal to 4.9 t squared. Okay, so this is my curve, and for part A we need to find the velocity, which we said that the velocity is equal to what? To the slope of the tangent line, which is m, that we took in the first part, m, which is equal to that formula, and I need to find the slope of the tangent line at or after 5 seconds. So after 5 seconds means when t is equal to 5. So I have the curve and I have the point, which is t is equal to 5. Okay, and this formula I will apply it directly, but what is my a? A will be the time. So v of t will be equal to the limit when h goes to 0 for f of t plus h minus f of a of t over h. Okay, since I need to find the velocity or the slope of the tangent line for s, for the curve s, or here I can find I can write s since the function is denoted by s. Okay, so I have here the t, which is the point, which is equal to 5. Since I need to find if I need to find the velocity in general, if the question was find the velocity of the ball without this part, then I will find it in general, in terms of t. The velocity at the end will be in terms of t. But since here we have the question requires us to find the velocity at exactly t is equal to 5, Then I'm gonna substitute t with 5. So v at 5 will be equal to the limit when h goes to 0 for s of 5 plus h minus s of 5. Okay, over LH. So I need to find what is S, the position at t is equal to 5, and what is the position at 5 plus h. Let's start with the position at 5. The position at 5 is equal to what? To 4, applying the formula. 4 times 9, 5 to the power 2 will be equal to 122.5. For S, 5 plus h, this will be equal to what? To 4.5, and instead of t, I'll write 5 plus h squared. And if I apply the formula that says if I have addition of a plus b squared, this is equal to a squared plus 2ab plus b squared. So my a is the 5 and the b is the h. This is equal to 0.9 times 5 squared plus 2 times 5 times h plus h squared. And this is equal to 122.5 plus 10 times 4.9, which is equal to 49h plus 4.9h squared. Okay, so I find the 5 at s at 5 and the s at 5 plus h. Let's go again to the formula. Limit when h goes to 0 for what? For s of 5 plus h, which is equal to this 122.5 plus 49h plus 4.9h squared minus what? Minus 122.5 over h. This will go with this, and then I'll have limit when h goes to 0 for 49h plus 4 minus 9h squared over h. If you substitute directly, you'll get 0 over 0. So I can take h as a common factor, then it will be limit when h goes to 0 for h 49 plus 4.9h over h. This will go with this, and finally I'll substitute with 0 by h, and I'll get 49 meter over per second. So this is the velocity at 5.